Hello, in this video I will talk about the dynamic memory allocation or the memory management in C programming. So the purpose of the benefit of using the dynamic memory allocation is that sometimes in some programs you don't know how much memory you will need, but the user determines how much is needed. So the program begins, and then whenever memory is needed, and you allocate memory, and then you free the memory. So here, let's say, so first of all, let me talk about the size of function. So let's say printf. Okay. Um, okay. So in here also let me use integer a equals to 5. Okay. Here, if I say, okay, so percent f. Okay. So I'm sorry, percent d, and then let's go to the next line. So here, if I say size of method, and then here let's say int. Okay, so I want to know how much memory is needed for the integer. So here I say compile it. Okay, so format specifies, so here integer, but the argument is type unsigned long. So here I can say long unsigned long, compile it. Okay, run it. Okay, now it says 4. Okay, so why do I need size of method? Because when you allocate memory, you have to say the size of. For example, we might have an employee struct. Okay, so employee has first name, last name, salary, age, whatever, and then you tell the compiler to find out the size of the struct, and then times whatever you need. If you need memory for the 10 employees, you multiply it with the 10. Okay. Now let's use this with the struct. Okay, so let me use type definition, and then struct. So let's say this will be for the cat type. Okay, cat type. Okay, and let's say we have just h for the cat. Okay, now here, so let me just delete this so that you are not confused. Okay, so here instead of int I say cat type. Okay, now let me compile it, run it. Okay, it says cat type needs 4 bytes. Why is it 4 bytes? Because we have integer h. So consider that I have another field, and let me just say this one for the I don't know. Okay, so let me just say x. Okay, doesn't matter what it is. So if I compile it, run it. Okay, now it says 8. So cat type needs 8 bytes because this integer 4 byte, this one is also 4 byte. Okay, now let me delete this. Okay, now let's allocate memory for this. So if I do this, okay, if I say cat type and cat1, okay, or c1, okay, this allocates memory, so static memory allocation. So now I want to have a, instead of having a cat type directly, I want to have a pointer to it. Okay, so let me say cat pointer. Okay, now let's allocate memory. We use malloc. Okay, and then we need to say how much memory we want. So here I say, so I need 4 bytes, okay? So I copy and paste here, okay, size of cat type, okay? So if, okay, so also here, let me say, so this will return the address location, and let me assign it to this one. So cat pointer, okay, um, and then here let me just display this address location. So I say P for the pointer, and let me use CP, okay, which is this pointer. Um, okay, let me compile it. Okay, so here it says implicitly declaring library function, this one. So which means we need to, so this is a warning. So this malloc is in the another library. So stdlib, okay, include, okay, stdlib library. So let me compile it. Okay, okay, not C, I'm sorry, H. Okay, semicolon, yes, so I need to forget to put one parenthesis, compile it. Okay, now let me run it. Okay, so this, if it is available, if memory is available, it returns the address location. But if the memory is not available in the operating system, it returns null, or you may not have permission or some access problem, then it returns null. So for this one, this returns a pointer to void. Okay, so just typecast it to cat type. Okay, so cat type pointer. Okay, so put this at the front. Okay, so let me just compile it, run it. Okay, so it displays that in here. So now let's change, let's pass this, okay, to a function. So let me just write the function here. So void, um, so for the name, let me say info, okay, just to keep it simple. So here as the parameter, I don't pass cat type, but I pass the pointer to cat. So here I say cat type and a pointer to cat. So let me just say ptr. Okay. So here let me just use printf. Okay. So printf. Then I want to display the h. So let me say h is what? Integer. Okay. So %d, comma, and so ptr dot h. Okay. So let's see if this. Okay. Also let me just change this one. So here call the info function. Okay, so info, and so as the parameter I pass the pointer of the cat. Okay, so this is a pointer. I pass the pointer, and as you see, yes, this is correct. So we pass the pointer to the cat type. Now let's see if this compiles. Okay, it didn't compile. It is because ptr is not a cat. ptr is a pointer to cat. So you use this one. So h. So the pointer doesn't have h. Cat has h. Okay. So here we need to say the thing pointed by this pointer, okay, which is this. Put this in the parentheses. Okay, now this highlighted one, this is a cat, okay, which means the thing pointed by this pointer, which is a cat, and then dot h. Okay, so now let's see if this works. Compile it. Okay, it compiled, and run it. Okay, h is 0 because we haven't assigned anything yet. Okay, so after we allocate the memory, let me say cp dot h. So let's say 5. Okay, so do you see the same problem here? So here cp is a pointer, it's not a cat. So we inside the parentheses I say the thing pointed by this and h. Okay, okay, and then we have the same thing here. Let me compile it, run it. Okay, h is 5. So the shorter way of this one is so here I can, okay, so here I say a row sign because this is a pointer. Okay, so with the pointer you can use this one in short. So arrow sign h. Okay, let me compile it, run it. Okay, it worked. I can do the same thing here in the function ptr. So instead of point I say arrow. Okay, compile it, run it. Okay, h is 5. I hope this is clear. Have a nice day.